All right, Math 1, this is EOC review number 9. It's saying, number 1 says the Swan at Ellsworth Pond had or has have been increasing the number of year in each year. It says, let's keep track. Let's just continue. Got 2, 4, 7, 17, and 33 swans each year for the past 5 years. First, second, third, fourth. Okay, fifth year. All right, you're not adding the same number to go up, and it is increasing. So you're multiplying to get to the next number. It's not perfect multiplication, but you are going up by um, multiplying or close to multiplying. Because if you multiply 2 times 2, you get 4. Then 4 times 2 is 8, but this is 7, so it's a little off. And then 7 is, if it was 8, then 8 times 2 would give you 16, and so on and so forth. So it's very close to an exponential function. So in order to get that exponential function here, it says what type of graph? This is an exponential function, and you can graph the points and you can see kind of it increasing. And since you don't have enough space, you can start here at 0, go up 2, 4, 6, 8, 10, 12. You can go up by 2 so you can have enough space to graph all of it. So this is more like an exponential function. So in order to figure out, it says how many swans should Felix have to expect the next year if this trend continues, and explain. So we're going to do exponential reg and look at the function table to see. Okay. So to do exponential reg, we're going to go to stat edit and we're going to type in, I'm going to clear second plus 7, 1, 2. So let's go to stat, let's go to edit, and let's type in these points. There are 5 of them. 1, 2, 3, 4, 5. Automatically, we're going to start. It didn't give us the starting number, 0 number. So we're going to start with 1 and not 0. And then beside 1, the first number is 2. The second number is 4. The third number is 7. The fourth number is 17. And what's the fifth number?
33.
33. All right, so now we're going to do exponential reg. So that's stat, calc, expo reg, that's down at the bottom. Yeah, it's like 10. And this is the time you're going to do L1, comma, L2. So L1, comma, L2, comma, vars, Y bars. How many times you press enter? 3 times. So now we can view the function table. So what 2 buttons do we press to view the function table? Second graph. So when we go to second graph to view the function table, we want to know how many swans could Phoenix expect next year. So next year will be the 6th year, right? So what's the 6th year about? What? 65.8. It's So it's about 66. Yeah, it's about 66. Okay. So any questions? All right, cool beans.
I was trying to grab the points of the graph.
Oh no, you are. I'm just not going to graph the points.
Oh, great.
That's right. You're supposed to do that. Graph the points. It says Alice. Oh, let me pause. Give you a chance to do the second one. Okay. Let me pause for the call. Okay, so let's look at number 2 where it says Alice finds that her flower buds multiply each year. She started with just 24 tulip plants. After 1 year, she had 72 plants. 2 years later, she had 120. It says find the linear model. So that means this is a linear equation. So we're going to do linear regress. So I'm gonna go second plus 7, 1, 2, and go back to stat edit. And I'm going to type in my X is year, it's time, and my Y is the flower buds, the total number of flower buds. So we got 0, 1, 2, 3, 4 for X, 0, 1, 2, 3, 4 for X. Okay, and then for Y, besides 0, starts off with 24, and then it goes to 72, and then it goes to 120, and then it goes to, what's that, y'all? 168, and then 216. Okay, that's how it goes. All right, so now we're gonna go. Parker, you go to stat.
Oh, I got it.
Oh, you got it. Okay, calc and then lean reg. Okay, and so this is what you get for your linear equation. Y is equal to
48x.
48x plus 24. The starting amount is 24.
Plus
You see right here, if you didn't know, you find the slope by using the slope formula y2 minus y1 over x2 minus x1. And you could have just picked 2 points. The starting amount is 24 because it started off with 24 butts. So you could have did it that way too if it's calculated inactive, okay? All right, so now it says suppose Alice discovers she counted wrong the second year. So first year, still the same as, let's write the table, x, y, 0, 24. And then the first year is still the same, 172. But then the second year, it's wrong. It's actually supposed to be 216. So this is 2, it's 216. So now the rate of change is different. So it's no longer linear. So now it's the exponential model. So instead of, now we're going to type this in and do exponential function because it says find the exponential function. So let's type it in. Let's do the exponential function instead. All right. So remember, look, it's a times b to the x power. The starting amount is going to be 24. So this is 24. And what can I multiply times 24? 3. So it's going to be 3, right? And then 72, do I get 3 also? What's 72 times 3? Does that work? Yeah. So it's, this is the equation here. This is the equation. The common ratio is 3 to the x power. Got it? Does that make sense?
Yeah.
All right. So now I'm going to pause to give you a chance to do number 4.
Yeah.
Okay, so look at this one. Number 3 is saying that Catherine has heard that you can estimate outside temperature from the number of times a cricket chirps. Okay, it turns out that the warmer it is outside, the more crickets will chirp. Okay, that's really kind of true too. She has these 3 pieces of information. So the first information, it says a cricket chirps uh, 76 times at 56 degrees. So this is the ordered pair right here. This is another ordered pair. So you got 2 ordered pairs that you can make, that you can write into an equation. So you got, this is x, this is y. You got 76 and you got 56. You got 212 and you got 90. So we're going to do lean reg again to see what the equation is. So let's, second plus 7, 1, 2, and go to stat, edit, and type in the 2 ordered pairs and do a lean reg. Okay. Then go to stat, calc, lean reg. And what's going to be your linear equation? Y is equal to what?
0.25x plus 37.
Very good. That's your linear equation. This is your slope. This is your starting amount or your y-intercept. This is M. This is B. Okay. All right. I'm going to pause for the call, see if you can get number 4. All right. So look at this one. Number 4, it says this table shows the value. It says f of x is equal to, this is a quadratic function because you got an x squared term, plus 4 is greater than the value, wait a minute, yeah, is greater than the value of g of x, and this is an exponential function, which is x to the second, over intervals 0 to 8. So from 0 to 8, okay? So these are the x values that we're using for both of these equations. This was the first one, the quadratic one, um, x squared plus 4, and this is the exponential, y is equal to 2 to the x power. So now it says as x increases, this is our x, will f of x always be greater than the value of g of x, and explain. So let's see if is it always going to be greater. So look, this is going from 4, then it goes to 24, then it goes to 84, then it goes to 184, and so on and so forth. Now look, it's going to, at some point it's going to loop back around and go in the other direction. So is it always going to be greater? No, it's not always going to be greater, because this is going to keep going on and getting bigger and bigger and bigger, and this one's going to loop back around. This one's going to get bigger and then loop back around and go back in the other way. So no, this one is going to be a no. This is a parabola. It's going to loop back around and go up in the other direction. So this is definitely a no, um, because the values are going to go up. It's going to reach its maximum point, and then it's going to go back up again. Okay. All right. So this one is a no. It's a U shape or parabola, and it's going to go back up again. Okay. Or not back up, back down. I said up. It's going to go back down. All right, so let's look at number 5. Number 5, this is the sequence here: 7, then 10, then 13, then 16. How is this going up? This is going up by what? 3. So this linear or exponential? It's linear, because you're adding 3 to get to the next number. Okay, so it's linear. Determine a function to describe this. Okay, look, the starting amount. This is the first number. What was the number before it?
4.
4. So b is equal to 4. And what's the slope? What is it going up by?
3.
So the equation is going to be y is equal to what?
3x plus 4.
3x plus 4. Okay. So now the 20th number, just plug in 20 for x. So this is going to be y is equal to 3 times 20 plus 4. What's 3 times 20?
60.
This is 60 plus 4.
64.
So the 20th number is 64. This is the 20th number. Does that make sense? All right. Are you still writing? You still writing? Okay. It says a manufacturer keeps track of the monthly cost by using the cost function that assigns a total cost for the given number of manufactured items X. The function is, this is the function right here. What is a reasonable domain? Okay, look, it's starting at 5,000 and it's going up every single time. Okay, so reasonable domain. What does X represent in this problem?
The slope.
No.
Oh.
No.
Manufactured items.
The manufactured
The total
items.
cost for the number of manufactured.
Okay.
Oh.
So
I
it's
see it.
so can since this represents the manufactured item, can it be a negative number? No, it can't. So it has to be 0 or greater than. Do you see what I'm saying?
Mm-hmm.
So X has to be greater than or equal to 0, the domain. Okay. It can't be a negative number, because you cannot have a negative manufactured item. Does that make sense?
Did you plug in 2,000 for the next one? Like we did.
It says what? Let's see. What is the cost of 2,000? Yes. So you're going to rewrite the equation, and you can plug in 2,000 for x. That is correct. If it gave us a cost and it asked us how many items, we plug it in for y and solve for x. But since it's telling us that this is that many items, then you're going to plug in 2,000 for x and solve. Does that make sense?
Yeah.
All right, so go ahead and figure that out.
I got 7,000.
Very good. You said 7,000 what?
600.
600. Okay. All right. You ready for next? Okay, so here it says, Which scatter plot best represents a linear growth? Which one represents a linear growth?
B.
B does, yeah.
B.
B.
Oh.
Linear. It's linear, not exponential. It's linear. Number 2, it says, which scatter plot best models an exponential growth? A does. Exponential growth.
That is like no correlation.
That's no correlation. Yeah, it's all over the place. That's yeah, and then that scared me. That's okay, babe. All right, it says which table represents an exponential function? That means you multiply to get to the next number. So you said which one? B. The only thing is you can't multiply a number times 0,
D.
so it can't be this. Cause what you say?
D.
D. No, you still starting with 0. You can't start with 0.
Oh, I didn't even
You
see
can't.
that.
Yeah, it's starting at 0. This can't work. You can't multiply something times 0 to get 3.
A.
It's not possible.
Dude, it's not. The multiplying. Oh.
You can't. I can't multiply any. What is it?
C.
C.
What is it
Okay.
multiplying? Oh, 7. She was talking about with D that it starts at 0, 0. You can't multiply anything by 0 to get. I thought it was A. I thought it was 2.
But do you understand now how you got to eliminate those?
Yeah.
Okay.
You got to pay better attention.
Yes. Exponential function means multiplying. If it was linear, you can start at 0. But it's exponential. You can't start at 0. All right. Number 4, it says the table shows this is f of x, this is g of x. Okay. It says which statement compares f of x and g of x over intervals? So it's going from 0 to 5. Let's look at f of x, the outputs. You went from 0 to 1. Well, you already know it's not exponential because it's starting at 0. So no exponential. So you're going up. So this has to be linear. Does that make sense? All right, what am I adding to get to the next number?
3. Well, and the first one is no.
Mm-hmm. So here, no. There isn't, is it?
It's not. No, it's not.
Okay. What about this one here? What is this going up by?
I don't think that's accurate. I don't think it's like this.
So both of these are non-linear, aren't they?
Yeah.
Okay. All right. So let's look and see what they're talking about. It says the graph of f of x always exceeds. Okay. Is it always exceeding? Is f of x always greater than g of x? No, it doesn't. No. So A is not it. The graph of g of x always exceeds. So is g of x always bigger? So here it's bigger.
Yeah.
Here.
So no, not always.
No, not always. It's not always bigger. Do you see that?
Yeah.
So no.
Wait, negative 2 is bigger than 0.
No, 0 is bigger than negative 2.
Oh.
And then it says the graph G exceeds the graph of F. So G is bigger than F from interval 0 to 4. So G, let's look at G. G is not bigger here. This is bigger here.
So
G.
that's automatically wrong.
Yeah, that's not right.
So it's D.
And it says the graph exceeds, F of x exceeds the graph over intervals from 0 to 4. And it does.
That's right.
Yeah, that's right. D is the correct answer.
Oh, are we supposed to write it to us?
Yeah, no, it's okay. Number 5, it says which statement is true about the graph of an exponential function? All right, so think about exponential functions. It says the graph of an exponential function never exceeds the graph of a linear or quadratic. Never? You gotta be careful when you use the word never. It never goes faster? That's not true. Okay, exponential functions are actually they grow more rapidly than a linear function does. The graph of an exponential function always exceeds the graph of a linear and a quadratic function. This is a possible answer, okay? Except for if it's exponential decay, then it does not. So I don't know. We'll see. The graph of an exponential function eventually exceeds the graph of a linear and quadratic. Okay. Okay. We'll just finish this last one. The graph of an exponential function eventually exceeds the graph of a linear, but not a quadratic. This is, well, eventually exceed. I got to check on the answer for this one because it doesn't. I understand what it's saying, but I just want to be 100% sure before I tell you that that's the correct answer. Okay. So the rest of it, honestly, you should be able to finish the rest of it on your own. It's really not that difficult. Okay. All right. You're welcome. All right, so let's see here. It says, which statement best describes the comparison of a function f of x, g of x? Okay, so here, start at 0, then we go 2, 4, 6. So this is going up by 2. And then this is negative, this is going up 1. And then this is going up, so this is going up 1, and then this is going up 9, 3, and then this is going up 3, 6, 5, and then this is 1, 2, 3, 4, 5, and this is going up. Let's see, 6, 7, 7. It's going up 7. Ooh, okay. All right. So there we go. All right, so it says the value of f will always exceed. This one is going to always succeed g of x. Okay, and it says g of x will always succeed. Hmm. F of x exceeds. F of x exceeds g of x between these intervals. Hmm. This is true. And then the values of f g of x begin to succeed values within 4 and 5. No, that's not true. Okay. Which function modeled in this table? So let's see, 1, 2, 3, 4. This is going up. This is you multiplying. So you're multiplying by 5. Well, 5. So yeah, you're multiplying by 5. So the answer here is going to be D. Okay, because you are multiplying by 5. So this is an exponential function. So when you type this in, stat edit. mm, Okay, so we got 1, 2, 3, 4, and we have 8, 40, 200, and 1,000. Okay, and we do exponential reg. It's the last one. Oops. So see, so 1.6. That's the same as 8 divided by 5. See, okay? So this is your answer. And also, to get the starting number, go backwards. And what did you do? You multiply by 5 to get this way. So divide by 5 to get that. That's why they got 8 divided by 5 as your starting number. This is your starting number because you're working backwards to get your zero number. You need your number before that. So 8 divided by 5 is going to give you the number before that. And then your common ratio is actually 5. So that's why D is your answer there. All right, it says f of 12. So that means x here is equal to 12. That's the number in the parentheses. Again, this is x. It's 12. All right. Which is the function? Okay. So we know x is 12. So when we write this, we can write f of x is equal to, and replace, wherever you see 12, replace x. So that's going to be f of x is equal to 4x minus 20. Okay. So that's 4x minus 20. That's this one. Okay. Oh, that's minus 12. Ooh, minus 20 is right. That's minus 20. I'm tripping. All right. Number 9, a sample of 1,000 bacteria becomes infected with the virus. Each day, a fourth of the sample dies due to a virus. Okay. So it's decay. Um, so one fourth of it is dying. All right, so it says a botanist, so it's going to be y is equal to c parentheses 1 minus r to the x or t power. So it's 1,000, okay, and then or it's equal to 1,000. 1 minus, and if 1/4 is 0.25 to the x power. That would be the equation. Oh, that's this right here. Okay, yeah, that's this. So they wrote the equation for you. It says a botanist studying the bacteria models the population of the bacteria with this function. That's the same thing I wrote here, but it's supposed to be to the x power or time in days. What is the range? The range is the y. So the range has to be, the population can't be a negative number, so it has to be um, the starting is at 1,000, so it goes from, okay, and it goes down. So the highest it's gonna be is 1,000, and then it's going down from there. So it's gonna be less is zero, any real number such that, so it's gonna be any number that is t. T is time though. That's not it. It's not asking for. It's saying range, not domain. So that's not it. T is time, and that's not it either. So it has to be between these because it's talking about the range. It's talking about y, p of t, not t itself. So this is saying that it's any real number between 0 and 1,000. That's true. Any whole number, no, because it can be a decimal. So no, it can be a decimal. In fact, it can be a part of a, yeah. So it's gonna be, let's see. Number 10, it says the graph shows the height y. So this is the height along the side. Y meters of a rocket above sea level in terms of t time. This is time on the bottom. Okay, 6. Okay, and landed at sea level. All right. So what does the x-intercept represents? This is where the rocket hits the ground right here. Okay. So it says the x-intercept. It says the height from which the rocket was launched. No. The time that it took for the rocket to return to the ground. Yes, to return to the ground. So, yeah, that's what it represents. And the total distance, no, it's not the total distance that the rocket flew. Mm-mm. The time it took for the rocket to reach the highest point, no, that's up here. That's not down here. So the best answer is the time it took for the rocket to hit the ground. Okay. All right. That's it on that one. Okay. Have a good one, y'all. Bye.